Hello. So far in the discussion of engineering graphics, we have understood what is projection. One word definition of projection we have understood that it is image. Then method of projection as orthographic projection. What is orthographic projection? Then method of drawing like first angle method of drawing, second angle method of drawing, third angle method of drawing and fourth angle method of drawing. So it is concerned to the reference planes we have considered, which are the horizontal plane and the vertical plane, and these are the quadrants with reference to the observer as first quadrant, second quadrant, third quadrant and fourth quadrant. So first angle method of drawing, by this we mean that when the object is placed in the first quadrant. As well, we do have the background of how to get the images of a point in the given quadrant. So that is, in case of first angle, when the point is in the first quadrant, we know or we have understood how we can take the image of a point, as well as various images we can take, like the front view, which is elevation, the top view as the plan, and the profile views. Now we will extend our idea in today's discussion, and we will extend the idea to get the projection of line. By line, I mean it is a straight line. That means I can describe the property as it is the distance. So if I consider 2 points, let us say A and B on the line, so this distance between A and B, when it is expressed as the shortest distance, I get this as a straight line, right? And as well, it is having only one dimension, that is length. So we are extending our idea from point, which is the dimensionless drawing, to giving it one dimension, that is length. So in today's discussion, we will try to understand how to get the images of a line when the line is placed in the first quadrant or in the quadrant in various conditions. So actually we have discretized the final condition of a line by into number of steps, right? So that is how we will try to understand as the cases. So any given condition can be said that it will be combination of all these cases what we are seeing, or maybe if a given condition of a line is given to me in the quadrant, I will be taking help of all these situations or conditions of line to get the solution. So out of which then we will consider the first case as the most simplest case, I'll say. Let us say when there is a line AB, of course it is in the first quadrant, is the condition is stated as line AB is parallel to both HP, that is horizontal plane, and the vertical plane. So this is the first case. We will try to understand how the orientation of the images will be in this case. So for this, first we'll try to understand this in a three-dimensional approach or a pictorial approach. So let us say, so this is the vertical plane, and this is the, say, horizontal plane. So this intersection of the vertical plane and the horizontal plane is the reference line XY. So I say that this is the vertical plane, and we will be getting the front view in this plane, this is the horizontal plane, and we will get the top view on the horizontal plane. Now the first condition is said that line AB is parallel to both HP and VP. So let us consider this as a line, right? So this is the line which is in the first quadrant. So assuming me as an observer in the first quadrant, if I say, then the vertical plane is this board and the horizontal plane is the floor. So it is said that the line is parallel to both HP and VP. So if I place, or if I show the line as, say, this as the line, which is line AB. So this line AB is, these are the ends of the line, such that the line AB is parallel to VP as well as it is parallel to HP. So let us say this is the end A and this is the end B, and the line is parallel to VP. That means I can say all the points of this line, they are at the same distance from VP. When I say that the line is parallel to HP, then all the points on this line, they are at the same height from HP. So the distances of the ends A and B, they will be same from both HP and VP. Then only it will be parallel to both the planes, right? So as an observer, now to get the two views, then I have the first option of standing in front of the object and looking at it. So I get the first image as the front view image, and the second image I have to look at the object from the top. So I get the top view image on the horizontal plane. Now in orthographic projection, the conditions of the projectors are such that they will be parallel to each other and perpendicular to the plane on which we are taking the image. So for the front view, the projectors will be projectors of A and B. So now why A and B? Now I am going to, or we are going to take images of the end A and the B. Let us say we know the conditions of this A and B somehow, or maybe in the problem that will be stated directly or indirectly, that we have to understand. So if I have information of any 2 points of that given line, definitely I can get the image of that line. So let us say here I know the conditions of A and B. So I will project, or we will project A, and then we will project B. And we know that A and B is a straight line. So the image of the line AB also will be a straight line. So instead of getting images of all the points of the line, we will just take image of A and B, and we will join them with the property of straightness with each other, that will represent the image of that line. So projector for front view, they will be parallel to each other, and definitely they will be perpendicular to the plane on which we are getting the image. So let us say these are the projectors. So somewhere here, wherever this projector strikes the vertical plane, we will get the image of A as, say, A dash, and wherever the projector of B will strike the vertical plane, I will get the image of the point B as B dash. So we get the images A dash and B dash. Now when we are standing in the front and looking at the points, so when we are standing at the front and looking at the ends, we will be able to see the heights of A and B, right? So and that height will be represented as the shortest distance from the reference line XY, which will be the perpendicular distance. Fine. So when we say that the line is parallel to HP, when the line is parallel to HP, so height of A and height of B, that will be same. So we'll get the image H dash, A dash at height h and image of b dash also at the same height h. So when we join a dash and b dash, so a dash b dash is going to represent the front view of the line AB. Right? Now, as we can see, when the line is parallel to HP, the height of A and height of B are same. That means I will get the image A dash B dash of the line, the front view image of the line parallel to the XY line. Right? So that is how we are getting the front view image. Now, the second image is the top view image. So we will be looking at the line from the top. So now we will drop the projector from A. So wherever it meets the horizontal plane, there I will get the top view image of A as small a, right? Then we will drop the projector. So this is the projector of A for the top view. Then we again drop the projector for B. So wherever it meets again the horizontal plane, here I will get the top view image of B as small b here. Now when we are looking at the line from the top, and we have said that the line is parallel to VP, the line is parallel to VP. So when I am looking at it from the top, the distance of BA from the vertical plane and distance of B from the vertical plane, they will be same. So that means, let us say if this distance is B millimeter from the vertical plane and distance of A is also B millimeter from the vertical plane. So when looking from the top, this distance also will be B mm and this distance is also B mm. So again what we get the condition? We get, so when I join AB, this AB is going to represent the top view of the line AB, and here also we see that the top view also we are getting parallel to the XY line. Right? So this was the understanding in three-dimensional. Then what we do to bring these two planes, horizontal plane and the vertical plane, into a single plane. So we rotate the horizontal plane by 90 degrees. So when we turn it, so this image also will turn and we will get this image to be turned and as this as AB. So let us see how we are going to draw it in orthographic drawing. Fine. So for orthographic projection, we start with the reference line. So this is the reference line. First we will draw, which is XY line. So we are talking about a line which is AB. So let us say partially we have the idea of end A and end B. So let us say somehow I know the projectors. So 1 point, 1 projector. So there are 2 points. So there will be 2 projectors, and projectors will be perpendicular to the reference line. So this is projector of A and this is projector of B. So let us understand it. This is the understanding we have seen how in the 3-dimensional. Let us understand it directly in orthographic projection. So if you are looking at it from the front, so in first angle, the area above the XY line is the area for front view, right? And the area in front of the XY line is the area for top view. So when you are looking at it from the front, we know that height of A and height of B, they are same because the line is parallel to HP. So in the projector of A, on the projector of A, I can mark, if I know, let us say what is the height of A, say H. So I get this as the front view image of the point A dash, right? Which is at height H from the XY line. Similarly, I know the, let us say I know the projector of B, and B is also at height h because line is parallel to HP. So again I can measure h and I can mark the front view image of point B as B dash. So when we join A dash and B dash, we get the front view image of this line. So this is the front view image of the line. Now let us understand it this way. When the line is parallel to HP, its front view image will be parallel to XY. This is for sure. When a line is parallel to HP, its front view image will be parallel to XY line. Now, or the reference line. Now we are not talking about the length of this line. Fine, we will talk about it in the latter stages, how irrespective of the length, when a line is parallel to HP, of course the front view of the line will be parallel to the reference line or the XY line. Similarly, the top view was distance of A from XY is B, distance of B is also B millimeters from B. Why? Because the line is parallel to VP. So when the line is parallel to VP, when I am looking at it from the top, distance of B and distance of A will be visible, which are same as the line is parallel to VP. So this is projector of A. So maybe at some B millimeter distance, so this will be the top view image of A, and at B millimeter distance it will be top view image of B. So when I join AB, I will get the top view image of the line AB. So here, so this image what we got, this is the top view of the line or the top view image of the line. Now in earlier cases we have as well talked about how to get the profile view, or in first angle method we will go for the left hand side view. In projection of points we have seen that. So now if I want to get the side view, have a look at it. So if I want to go for a left profile view, that means looking at this line, when this line is parallel to VP as well as parallel to HP, the profile plane is perpendicular to both HP and VP. That means this line will be perpendicular to VP. The profile plane. So obviously when I look at it from the left side, I'll be able to see this line simply as a point, because I'll be getting the image on the left profile plane. So if here as an observer, this is for front, so when I move to the left and look at the object from the left side, so the left profile plane is here. So when you will look at A and B, so I will be getting the image of this line here on the profile plane as A double dash B double dash, which will be a point. So let us check that with the fundamental of first angle method of projection, whether we really get this as a point or not. So from the front view image at a comfortable distance, we will consider the second reference line as x1, y1. So I just extend this. So this is xy. So now I have to take side view or the left hand profile view of the point A as well as point B. So let us talk about first point A. So I can simply drag the height of A parallel to xy on the, so I'll draw the locus of A, which will be parallel to xy. Then I'll take the width, so this B millimeter till of A till this origin, and rotate it and then project it. So this is height of A and this is the width of A. So this must be A double dash. Fine. Similarly, now I project height of B, which is same. I project height width of B, rotate and project. So again, I get this intersection point as B double dash. So the left hand profile view or the left hand side view we will get for this line to be as a point. So this is how we get the orthographic projection of a line when it is parallel to both the reference planes. So now in the second case we will see the second case to be when a line is parallel to one plane and inclined to the other plane. So let us see the second case where line PQ, so we consider there is a line PQ which is parallel to VP and inclined to HP by some angle theta. Right? So again, let's see. So this is the vertical plane. So we will get the front view on this plane. This is the horizontal plane. We will get the top view on the horizontal plane, and this is the reference line XY. And let us say there is a line which is said as parallel to VP and inclined to HP by angle theta. So again, let us look at our line PQ this time. So it is said that the line is parallel to VP. That means if the line is parallel to VP, then all the points of this line will be at the same distance from VP. But it is said that the line is inclined to HP. HP is the floor. If the line is inclined to HP, then all the points of this line will not be at the same height from HP. So heights of all the points will be different. So the distance of all these points from VP is same. That is why the line is parallel to VP. But the heights of all these points on the line are different. That is why it is inclined to HP, and this inclination with HP is said as, let us say, theta, whatever that inclination. So if I try to understand this condition, so say, so there is this line which is inclined to, so our line is PQ and it is inclined at theta. So when we are looking at it from the front, we are able to see this inclination. The relation of inclination is with HP, so that is visible in VP. So theta, which is the inclination of the line, which is the true inclination of the line, is available in the VP, that is in the front view. So again we will apply the same funda. So we will take two images, that is one is looking at it from the front, the other when we look at it from the top. So projector conditions, orthographic projection, the projectors will be parallel to each other and the perpendicular to the plane on which we are taking the image. So when we are taking the front view, the projectors will be parallel to each other and say wherever it intersects or meets the vertical plane, I will get the front view image of the line as this. So this is say P dash and this is Q dash. Now from the front view I will be able to see the heights of these two endpoints P and Q, but the line is inclined. So if P is at a distance H, Q will be at some other distance, let us say it is some H dash distance from. So I get the front view image also inclined to the XY line. If I just extend it this way, so I see that the image of front view image is inclined to the XY line. Now we take the top view image. For top view image we will drop the projectors. So this is projector of P, this is projector of Q. So again, if we see wherever they will meet the horizontal plane, we will get the images of P and Q. So let me show you this way. So we have passed the projector through P and Q, so we get the front view image in the VP. Then we pass the projector for the top view. Projectors are perpendicular to each other, so I get the top view image of this line on the horizontal plane. So say this is the top view image P and this is the top view image Q. So when I join PQ is the top view of the line and P dash Q dash is the front view of the line. Now when we are looking at it from the top, it is said that line is parallel to VP. So and P and Q, they are at the same distance. So looking from the top, if P is at B millimeters from VP, Q is also at B millimeters from VP. Right? Again, in the last case only we have seen when the line is parallel to HP, we got the front view as parallel to XY. When the line is parallel to VP, we have got the top view as parallel to XY. Here the line is parallel to VP, so that is why we got the top view image parallel to the reference line XY. We will talk about the length when we discuss the orthographic. So let us discuss the orthographic projection of this condition. So this is the reference line XY. So this is projector of P, this is projector of Q. So when the line is inclined to HP, so heights of P and Q will be different. So say height of P is some H, so I get this as P dash, but height of Q is different than P, say it is some H1, so I get the front view image of Q as Q dash. So I get the front view image of the line, as inclined to the XY line. Now when we are looking from the top, P and Q, they are at the same distance from the XY line. So say it is B millimeter, so I'll get the P point here, and Q is also B millimeter from the reference line, so I get PQ as the top view of the line PQ. Now let us talk about the length of this line. So let us say the length of this line is L. The length of this line is L. Now the line, you need to listen to it carefully. The line is parallel to VP, right? The line is parallel to VP. The image is on VP. That means the image is also parallel to the line, right? The projectors are perpendicular to VP. So the projectors are as well perpendicular to the image because the image is on VP. But the line is parallel to VP, therefore the projectors are as well perpendicular to the line, right? So the condition of the projectors is this. So this same length is getting projected. So if this is L, that means the front view length, this is also equal to L. So that means here I get what is L? L is the true length of the line. So here what we are getting, when the line is parallel to VP, we are getting the front view length of the line to be equal to the true length of the line. And why this has happened? Because the line is parallel to VP. So we have to keep this in mind. When a line is parallel to VP, so I'll get the true length in the VP, or the front view image will give the true length of the line, or the front view length will be equal to the true length of the line. Now when we are looking at it from the front, this is height H and this is h1, this is the same length L. If that is the case, that means as well the inclination what we are able to see in the front view, that inclination is also the same as theta. So that means here the inclination what we are getting of this front view image with the reference line, this inclination is also the same as theta, and theta is called as the true inclination. So theta in first angle in projection, when we say theta, theta is the true inclination with HP. So the true inclination with HP is named as theta. So what we have seen here, when the line is parallel to VP, we got the front view length equal to the true length. Now what about the top view length? So when we are projecting, these distances are same. When the line is inclined in this fashion, so this is the projector for P and this is the projector for Q. That means this much, when I am looking at it from the top, I am not able to see the true length of the line. So the top view length is not equal to the true length of the line, and in first angle, in orthographic projection, this length is called as, so whatever this top view length is, this top view length, we call this as the projected length. Projected length. And the projected length, always in orthographic projection, the projected length will be always less than the true length. It can never be greater than the true length, as this as the condition. So here again, if I want to see what will be the side view or the profile view, so we'll simply apply the condition. So this perpendicular to xy, we draw the second reference line x1, y1. So how do we get the side view? We drag the heights to the left hand side view zone. So left, from my drawing, this is the left. So when we are looking at the object from the left to the right, we are getting the left hand side view. So for left hand side view, what we do? We drag the heights of P and Q, so parallel to xy line. So this is height of P, this is height of Q, or I'll call this as locus of P in the front view, locus of Q in the front view, right? Similarly, now I can take the distance of P from the xy, so I drag this till the x1, y1 and rotate it and project it. So this is the distance B of the P. So we project wherever it intersects with the height of P. I get this as P double dash, the side view image of the point P. Then Q, I project it. Again, this is the height of Q. So this is Q double dash. So P double dash, Q double dash, P double dash, Q double dash will be the left hand profile view or the left hand side view of the line in the given condition. So that also we can make it understand. So it is inclined to HP, parallel to VP. So as an observer, when I look at it, I'll be able to see this. See, if I place it this way, so you are able to see this image as a line perpendicular to XY, but the length will be shortened. So again, we'll be able to see the projected length in this left hand profile view as well. So that is the second case. So now we will move on to the third case, where the line will be parallel. We have taken parallel to VP. So now line will be parallel to HP and inclined to VP. So let us see how we get the images of this condition. So let us see the third case where the line MN is parallel to HP and inclined to VP by some inclination phi. So this is the vertical plane where we will get the front view image. This is the horizontal plane where we will get the top view image, and this is how the line is placed. So let us again see with the help of our line. This was the first case when the line is parallel to both HP and VP. Then the second case, line parallel to VP, inclined to HP. So from front view I am able to see the inclination theta. Now again I come back to the first case. Now it is said that the line is parallel to HP. So when the line is parallel to HP, that means the heights of all these points will be same from HP. And this is inclined to VP. That means the distances of all these points from VP will be different. Right? So when I look at it from the top, I'll be able to see this inclination phi. So again we take these projections, how the projections will be. So I can move faster this time. So height of M, height of N. So I get the front view image of the line as this, which is M dash, N dash, and in this case it will be the same height which is getting projected in the front view. Then for the top view, we will drop the projectors for M. So here maybe I get the top view image as M, and then I drop the projector for N. So somewhere here I get the top view image as N. Now when we are looking at it from the top, the distance of M from VP and N from VP, they are different. So we will get the top view image of MN, maybe something like this. So we will be seeing, so this distance of M and this distance of N, they are, if this is B millimeters, so this is some B dash millimeters, so they are different. So in the top view, I am able to see the inclined image. See again, when the line is inclined to VP, I get the top view image inclined. When the line is parallel to HP, I get the front view image parallel to XY, right? So we'll see the comparison when we finish off all these three cases. So let us see what will be the projection or the orthographic projection. So this is the reference line XY. 2 points, 2 projectors, and projectors will be perpendicular to XY line and they will be parallel to each other. These are the projectors. So projector of M, projector of N. Now the line is parallel to HP, that means height of M and N, they are same. So in front view if I mark, so this is M dash, this is N dash, their heights are same, so I'll get the front view image, front view as parallel to XY. Why this has happened? Because the line is parallel to HP. Forget about the length right now, right? So irrespective of its length, I'll get the front view image parallel. Now for top view image, M is at B distance from XY or VP and N is farther than N. So I'll get, say this is top view image M and this is top view image N. So we'll get the top view as this. So again, as we have worked out in the earlier case, if the length of this line MN is L, right? Now, the line is parallel to HP, the image is on the HP, that means line is parallel to image. Projectors are perpendicular to HP, so the projectors will be perpendicular to the image. The image is parallel to line, just now we have seen, that means the projectors are as well perpendicular to the line. That means in the top view, the same length has been projected. So we are getting the top view length this time parallel, to be equal to the true length. So here we are getting, in this case, top view length to be equal to the true length of the line. Now similarly, when I am looking at it from the front, so when you are, so this is the true length of the line. So if I tilt it, make it incline with VP, we'll be able to see this image to be a shorter image. So that means here the front view length is not equal to the true length. Rather here I get the front view length to be less than the true length. Right? So here the front view length we will get the projected length, and which will be definitely not equal to the true length of the line. Right? So that is how we get the projections. Then what about the inclination? When these conditions are same what we are seeing here, that means here the inclination of this top view image will be same that as of phi. So it is same that as of phi. And what is phi? Phi is the name given to the true inclination of the line with VP or the vertical plane. This is the name given to or nomenclature in graphics we are using. Right? So what we get here? So these are the three conditions we have seen. Acha. So now we can see how we can get the third view, that is the profile view for this condition. So again we draw the new reference line x1 y1 which will be perpendicular to xy. Right? So again for profile view, for left hand side view, it will be always to the right in the first angle method. So we will drag the height of m and n parallel to xy, so I can match the roller scale with xy, roll it to m and n, and we can draw the locus of m and n. Then we will draw the locus of m for the top view. From the origin we rotate and project. So height of m, width of m, this must be m double dash. Then again parallel to xy line, we drag the width of n, rotate it and project. So this will be n double dash. So we get m double dash, n double dash as the left hand side view or left profile view of the line. So the line is parallel to HP and inclined to VP. So from the left, if I see, I'll be able to see the left profile view parallel to the XY line. And that is how we get all these three cases. And the final case is the oblique condition of the line. That means when the line is inclined to HP as well as the line is inclined to VP. So that is what we are going to understand finally. But let us compare all these three. Now while comparing all these three cases, I will not be looking into the side views or the profile views, just to draw some inference out of all these three cases. Right? So say this is the reference line XY. Now let me talk about the first case when the line was parallel to both HP and VP. So say this is projector of A, projector of B. Line is parallel to HP and VP, that means heights and widths, they must be same. So we get the front view image and top view image both as parallel to. So this is what we have seen, A dash, B dash, AB. So front view and top view both to be parallel to XY line or the reference line. Now case 2, what we have seen, the line is parallel to VP. So say this is projector of P, this is projector of Q. The line is parallel to VP, inclined to HP. If it is inclined to HP, the heights of P and Q are different. So say this is P dash and this is Q dash. So that is how we got the front view image, and the top view image again parallel to the reference line XY. Why this has happened? Because the line is parallel to VP, so top view image came out to be parallel to XY. What about the lengths here? The front view length came out to be equal to true length. Why again this has happened? Because the line is parallel to VP and the top view length is not equal to the true length, rather it is less than true length. And in the third case we have seen when the line is parallel to HP and inclined to VP. So when the line, so this is the projector of M, this is projector of N, let us say we have taken N line, so line is parallel to HP. So now just by imagining the condition, when the line is parallel to HP, that means the ends will have same height. So I can directly mark here, so maybe this is M dash and this is N dash, so I will get the front view image, the front view to be parallel to XY line. And it is inclined to VP. So if it is inclined to VP, that means the distance of two ends from VP will be different. So I'll get the top view image of the line to be as like this. And I'll get, so here we have got the true length and true inclination as theta. And here we'll get the, so here top view length will be equal to true length. And here we'll get the front view length to be less than the true length or not equal to the true length. So these are the simple conditions which we have to understand and use to get the various required conditions when an oblique condition of the line is presented to us. So one thing is for sure we have understood that, see, when line was parallel to VP, we got the front, the true length and true inclination in VP. That means in the front view. When the line was parallel to HP, we got the true length and true inclination in the HP, that is top view. So we can draw out a conclusion, or we can make a statement like this, that when a line is parallel to a reference plane, in that condition the true length will be achieved in that plane only, or the image of that plane. Right? So when a line is parallel to VP, we will get the true length and true inclination in the VP, that means in the front view. If a line is parallel to HP, then we will get the true length and true inclination on the HP, that is on the top view. Right? So again, if we say when a line is parallel to a plane, we will get its true length and true inclination on that same plane. So if it is parallel to VP, that means front view will give me the true length and true inclination. If the line is parallel to HP, then the true length and true inclination will be achieved in the top view, and we have to use this to find the solution for the oblique conditions of a given line. Right? So that is all in this session. In the next session, we will discuss about the oblique condition of a line.